Check out my new tablet. Yeah, it's even got a screen, see? That's right, it's my new tablet. No, just kidding. This is an old NEC Versa. It's a circa 1994-ish. Originally would have been a Windows 3.1 laptop. And I believe this was a convertible model. The screen is removed by simply undoing these latches here. Which, oh, they swing out like this. You undo that one, and the whole thing just pops off. I got this laptop from an old friend of mine who had it kicking around his house, and he's been selling off his collection over the past couple of years. And he knows that I'm still into this stuff, so he went ahead and sent it to my house, which was kind of cool. And problem with this laptop is the display hinges were breaking off. It's a very common problem in these old laptops. I've already gone ahead and disassembled the display housing because I was kind of bored and I wanted to do it. So here's the display housing, the display hinge assembly housing bracket thingy. And I know not the right term and all, but anyway, it's a pretty interesting design. I've never seen anything quite like this before. The display has just one hinge, and the other side just sort of slides in there. It's unique, it's different, it's hip and poppin' fresh and all that, but it never really caught on. Nobody else does this. And just NEC. They're the only ones that ever did this. Yeah, the other side has no clutch. It's just sort of a free hinge. And well, like I said, I believe NEC was the only company to ever do anything like this. And thank God it didn't catch on. Because all the stress from that one clutch is transmitted right to here. These two lugs. And of course, they mounted these two lugs so far away from where the actual stress point is that it allows some torsion, and it just doesn't really distribute the force evenly. So naturally, these threaded brass inserts, which are molded into the plastic, have come loose. The plastic has cracked all around it, and there is no longer a strong enough point to withstand the stresses of daily life. It's kind of sad, when you think about it. So what are we going to do about this? What can we do? I have an idea. Now this is an experiment. I don't know what's going to happen. I don't know how well this is going to work. I have my doubts. I have more doubts than I have yeah, so you get what I'm trying to say. You get what I'm putting down, you get what I'm trying to put down. All right, okay, good. We've established that. So, what I've got to do here's my plan. I'm going to outline my plan. I am going to drill out 2 more holes. And we're going to insert a screw with a nut on the back end of it. A couple of nuts, maybe 1 or 2 nuts on this screw. One here, one here. Boom, boom. And we're going to put this back together. We're going to screw whatever's left to screw into. We're going to secure it as best we can. And then we're going to take some modeling clay and we're going to build a dam. We're going to encapsulate this entire clutch assembly. All right, you with me so far? We're going to put it back in there, like so. Then we're going to take, I'm actually going to need to put a couple of holes, maybe 3 holes in there, one for the injection and 2 for the new support points. And we're going to take this Loctite Instant Mix Automatic Mixing Epoxy, and we're going to fill this cavity with epoxy. What do you think? Think it'll work? I hope it will, because it's all I got. If this doesn't work, I don't know what I'm going to do with this laptop, because if the hinges are broken, it's fucking useless. And it's another vintage laptop that is otherwise perfectly functioning down the drain. We can't keep losing these things. We got to try to save them as best we can, and this is the best I could do, given all the parameters. But there's one catch. Once I do this, I can never take the display housing apart again. That's it. This is it. It's done. Because in order to take the display housing out in the first place, or take this all apart, I had to loosen this up. And once this is full of epoxy, this just isn't going to be possible anymore. Because, yeah. So how it goes together is this little, there's a split collar here. Really interesting design. I'm not so... I never got into the NEC line of laptops because they rub me the wrong way. I never liked them because they were never that durable, first of all. But let me see if I can kind of piece this together so you can see what I mean. This is it's an interesting design. Let's just put it that way, and not in a great way either. So let me put the cable back together, back through this hole here. Alright, only do one at a time. So, I know you can't see what I'm doing, and I'm not putting up a tripod. I don't want to hear it, guys. Don't want to hear it. Let's talk about Apple right now. Apple, oh my god. Apple, Apple, Apple. What are you doing to yourself? Stop hitting yourself, Apple. No, seriously. Stop it. Yeah, I'm not a big fan of Apple anymore. I think a lot of my loyal viewers will know why. Their new line of products is hardly innovative. They're just not even trying anymore. They're just not even trying. I just saw some really cool stuff. Went over to Best Buy, just to check out some of the new Microsoft Windows-based laptops, and I like what I see. I like what I see. I mean, Microsoft software has never been known for really any reliability, but sure isn't bad. Ooh, I broke that tab off. I was afraid that would happen. Oh well, better now than never, or better now than later, right? I guess I can still fix it. I've already fixed it once, I'm not fixing it again. I'm trying to get the display cable back where it needs to be here. There we go. So how this works is this is normally protruding out into here. It's got a little, like a mount on the end of it. And then we've got this piece here, which gets shoved so gently through this hole and into here, and that's our other hinge. So this is a passive hinge, this is our active hinge. Two terms that I just pretty much made up. Anyway, so what we're going to do now is we're going to start looking at drilling and mounting, and this is going to be fun. For years, for as long as I've been in the vintage computer, especially laptop collecting hobby, I've always run into problems where hinges would break, and I've never found a good way to fix this problem. And everyone's going to say JB Weld, but I don't know. I'm not into JB Weld because it doesn't work for every... It doesn't work for every laptop design, and this is one of those designs where it actually might work, but I need something that flows. JB Weld does not flow. Alright, so this is going to be my fill hole here. You'll see it in a minute. I'm going to actually stagger these. I'm going to put one there and one there. We're going to drill these out. You'll see in a second. So this big hole right here, This is the fill hole. This is where I'm going to inject the material. I'm going to drill these out diagonal, and that'll give the hinge some better support in either direction as it's being twisted back and forth. Okay? Alright, let's get on to it. Okay, so the plans have changed a little bit. I just realized this metal plate here mounts on top. This actually adds some structural strength to the hinge, but this is what mounts here. I'll show you how that looks. I just realized that that's there, taking some of the load off of it, but not enough. It kind of mounts like that. Okay. So I have an idea. This is actually good. This is going to work. I think this is going to work. I'm ready to. So what I ended up doing was I downgraded my plan to just putting in one coarse threaded screw into this while it's curing. It's going to work. I promise. Well, I don't promise. I hope. I want to save this laptop, and here's how I'm going to do it. All right. So what I got to do first is I've got to start damming up the whole mechanical part of the hinge. Maybe drop a little oil in there just to make it. I mean, not even be necessary actually. Maybe not. It's a pretty nice clutch. It's got multiple plates, multiple friction surfaces against. It looks like it might be under spring tension. I'll confirm that right now. Yeah, there's got to be some kind of a, maybe not. I was thinking maybe a spring tension in there somewhere. Doesn't appear to be the case. But we've got to dam it up with C4. No, it's plasticine. That's all it is. And that's going to stay in there forever. And it's going to protect it against infiltration by the epoxy solution. So this is going to protect our hinge from getting glued into position, which is kind of a bad thing. If that were to happen, it would be really bad. It would never work again, and I'd be sad, and you guys would get all pissed off, and I don't want that. So do that. We're going to dam it up, and that's going to kind of protect it in a way. And this stuff is cool because it never hardens. Even if it did, it wouldn't cause us any issues. So I'm going to just pack the stuff in there so that it fits. And so we're just going to keep all of that goodness at bay. Just pack it in there. There. So now we're ready to pour. Almost ready to pour. I'm going to go ahead and there we go. See, there we go. Alright, so let's take another look at that. So this is all packed up. I'm going to insert the heavy-duty hinge screws. We're going to start there, which are around here somewhere. Promise. Scout Sonder. I don't know where the fuck they are, but they're here somewhere. I know it. I know it. Where are they? It's kind of a. This is not a very organized job site, so to speak. Are these them? These look too finely threaded for this. And they work. And they seem to work okay. I just thread those in. Sorry if you can't see what I'm doing, but I'm describing it as best I can. Alright. We want this good and secure. We're going to unscrew these when we're done. Alright. Now I also want to insert some kind of a screw. No, that's okay because the plasticine will protect. See, what I don't want to see happen, I'll explain. I don't want to see this right here end up getting packed in with epoxy, because that will prevent a screw from going in there. Then we'll have to drill it out. It won't allow this one final screw to go in. See how that lines up like that? So these are going to come back out, then they're going to go right through here like that. Got it? When we're finished with the plastic or with the epoxy fill, this goes in here like that. Now this will be backed out. No, actually no, this stays in there. This actually stays in there permanently. This screw is too long. I'm going to have to either grind down the end of it or come up with another idea here. Let's see what other screws I have. This is too long. No, this isn't the one I chose, was it? I think I had a different one in mind. Actually, I had this one originally in mind. Let's see if that'll fit. This is a nice beefy screw. That's too... Nope, that's not going to work. Put this one aside. You can always take out the Dremel tool and grind it down. I may have to do that. This is a this is a little heavy duty stainless. That's not what we're going to use. But I hope you guys are picking up what I'm dropping. This is going to be a permanent fix. It will never be removed. That's a bit too long. Oh no, that's perfect. That'll do. Okay. But will it allow this cover to fit? Let's take a look. I'm looking, this is looking like an interesting little idea, and I hope it works. I don't know. I see no reason why that'll be a problem. Well, that should be just fine. Let's pull that back up. This is a fine threaded screw. Not what I had in mind, but it'll do the job. The jab. All right. Next, we get our epoxy mix together and we prepare it for pouring. Now this is going to be a permanent fix. Once it's done, it's done. You know, once the stuff sets, it's over. It better fucking work. So, you know, we're giving it more anchor points. We're giving it everything it needs to be happy and merry. And I'm hoping this all works out. All right, here we go. So, this Loctite adhesive that I'm using, it's a self-mixing epoxy. I'll show you. It's pretty cool. I've used this on a few different projects. It's good with plastics. It's good with everything. It smells horrible. Fucking horrible. Alright. So, the key to this self-mixing plunger is this tip, which includes a mixing straw. I'm going to pull it out here in just a second. You can see what it looks like. It's a self-mixing device that, when removed, let's see if I can get it out of here. It just has a bunch of channels that force the epoxy to kind of get intimate with itself here. The left and the right tube. Kind of need this for our government, to be honest with you. But it's got these channels that force the epoxy to kind of flow together as it comes out. It's a one-shot deal. You can use this nozzle once. Which is why the tube comes with two nozzles. We're going to just pull this off. And that's going to open up the chambers. This twists off like that. Sometimes. There we go. And I'm telling you right now, oh my god, if we had smell-o-vision, you'd be gagging right now. This stuff is nasty. Well, then you take this nozzle and you lock it in like that. And once you squeeze that plunger, It's all over, dude. That's it. So here we go. One shot to do this right. Then we're going to pop that screw in there. And you can probably see the stuff mixing. There it is. See it? Now this dries to a yellowish hue. I bought 2 tubes. I don't know how much of this I'm going to need. So I bought 2 of them. They're $4 a pop. And this stuff does harden really quickly. And we're just kind of pouring it in there. It goes in kind of like a syrup. You can already see it spilling over to the sides. Now, once it stops, I'm going to draw it back a little bit and let it kind of level off in there. And to help support those screw towers on the on this side over here, I'm going to get some more of this damming compound and kind of shove it down in here just to protect this side of the hinge. There we go. And we're going to take our screw and just pop it down in there. If it lets me. I might have to thread it in there, holy shit. There we go. Now that's going to bond to that screw. This is going to take overnight. There's a lot of epoxy there. It's definitely going to take a little while for it to fully cure. Now I'm going to fill up this chamber here with whatever's left. This is going to add a little bit of weight to the machine, but not much. You know, the thing weighs like 12 pounds, so I don't think anyone's going to notice. Honestly. Alright. So that's all kind of just going to gel out in there and intermix. That's the idea. But we pretty much have exhausted the whole tube here. And we'll throw it out. I'm going to take this towel here, or this little paper towel, and I'm going to kind of take away some of this excess, because that's going to cause us some problems. I may have to grind it away after. Anything I can't move out of there, but I think we'll be okay. Let's take a look. So, we've injected, we've filled up this right here. This whole cavity is filled. We then filled up this main cavity here, completely full of epoxy. If nothing else, it's going to allow that, it's going to prevent that piece from rocking like this. And that top plate right here is going to take a lot more of the stress, more stress than it normally would have. So it's going to work out. It's going to work out. We've dammed up the hinge. You can see there's no leakage. All right. Just want to make sure we don't get this epoxy on the piece, because that would really suck. So this kind of epoxy or similar compounds are used in the electronics industry for a process that is called potting, where you take like a small box that contains electronic components, usually sensitive or tuned or proprietary components. And what they do is they fill that little box after the part is made and soldered and tested. They fill the box with epoxy. And sometimes they use a rubber compound. Sometimes they use a hard epoxy like this. This dries to a hard rock solid substance. And what they do is they use that to do two things. Number one, it prevents anyone from trying to repair or reverse engineer that part, in theory. And number two, it also allows for better heat dissipation. Obviously, the heat dissipation is not a concern to us. Now, there's one other piece I want to fix. I'm going to let that cure for a while. It's going to be overnight, more than likely. It's starting to heat up pretty much. It's actually heating up quite a bit. That's what epoxy does. Same thing with plaster of Paris. It heats up. It's the chemical reaction that does it. But that looks pretty good. I think that's going to hold up quite nicely. It's fucking better. Alright. Oh, shit. Yeah, we want it to stay level. That's critical. We do not want that to cure in the wrong direction. Now, I've got this piece here. No, wait. Actually, that's the one I need to fix. So let me just grab that. Bring that back down again here. Because that's still in a liquid state. When it solidifies, well, that's a different ball game. We want to leave that alone. Okay, now right here, we have quite a bit of stress fracturing. Now what I'm going to do is I'm going to do the same thing. I'm going to dam all this up. Right here, just right there. Build a little dam. Or we could build a little piggy. But we're going to dam it up like this. Now this is not going to stay here. This is going to be removed at some point. And actually, where's that bracket? There's a bracket that goes in there, and we want to make sure that we do this right. I think what I might do is I might do this piece when it's all back together again, because I don't want to fuck it up. Yeah. When this is all back together again, I'm going to angle the laptop in such a way that allows me to perform the same procedure on that. So we're gonna basically we're gonna epoxy it all in just like we did here. It's already, look at that, it's already curing. And let's see, it's turning into a gelatin-like mass. Let's see what happens. The stuff is rated for what, 3,000 pounds? 3,200 pounds per square inch. It's the strongest stuff they sell. Let's see what happens overnight. Make sure that screw... Wow, that's hot. That is hot. Hot, hot, hot. Ooh. You can see the plastic is expanding. I'm not so sure I like that. Not that I expected anything different, but hey, you know what? I'm not so sure this was a great idea. Do I have a clamp? A C-clamp? I do somewhere else, but it's not here. Well, let's just see what happens. Maybe it'll all be okay. I can't seem to find my laser thermometer, so I'm going to use this ear thermometer. Let's see what happens. I think that's how this works. It's a pain in the ass. Oh, I got to turn it on. There we go. 107 degrees. It feels hotter than that, though. Let's do a couple more readings. It says high. That's 104 plus. Error. Error. Really? Low. It's just, this sucks. 136. Now the metal is dissipating the heat pretty well. When I hit the epoxy by itself, I get 143, 145-ish, 114, 104. So that explains why. Not many ear thermometers are meant to measure 150 degrees. At 150 degrees, you're dead. Yeah, do not pass go, do not collect $200, you are dead. So that's why we were getting erratic readings on that. error and high, and it's like if you're that warm, you probably, well, you know what? Skip the hospital. You're going to the morgue. So, yeah. All right. Well, there we are. It's cooking, and we'll see how it comes out. It's a bit warm. It's actually cooling off, and look at that. It's already hardening. Nice. It's been about an hour. Actually, a little longer than that, maybe. It's cured. It's nice and cool. So what we need to do now is start reassembling the display. Reassembling the hinge bar was a little different than the way it was supposed to be assembled. Normally, this piece here stays. This is the first thing you lock in. The actual hinge assembly gets slid into place, and that's what locks it down. But because we had the hinge plate or the hinge assembly already in place permanently, I had to take the flex. It's not a flex circuit cable. What am I saying? The display cable had to come out completely, and I had to mount the other lug, this little cast metal thing here. I had to lock that into place and then fish the wire through it, and that's how I put it together. So, okay. We're at that awkward stage where I'm going to need to mount this. Now, this is kind of precarious. This does not look structurally sound to me. Actually, I think I did this a little backwards. I think I'm supposed to lock this in first, and then, well, hold on. Alright, so I've already kind of worked this hinge a little bit, and it is a lot better than it was before. I mean, it's kind of a night and day kind of thing. There's a little bit of roughness to it, but that's to be expected. It is. But there is no play. There is no play. Oh, there is play, but that is actually between the where the shaft enters this bracket. There's going to be play there. Not much we can do about that. I'm going to do some damming right up in here. No, actually, how do I want to do that? Well, there shouldn't really be much movement in there anyway. I gotta do this carefully. Okay, you can see where I've built my dams and roughly how high we're going to go with this. So I'm going to go as high as I can, but we're going to take it slow, and hopefully we don't have a levee breakage. We have a little New Orleans in here. If you take offense to that, I'm sorry. Alright, here we go. Mixing it up, injecting away. Now, you'll notice that I dammed up the, there are some areas where the bezel clips in. I had to dam those up because there are some clips that broke off during disassembly. You gotta realize that ABS plastic, it's a great material, but it has its weaknesses. It gets fragile, and sometimes it breaks. Not much we can do about that. I don't know if I'm going to have enough epoxy to build up the massive reinforcement that I want to, well, build. I'm going to get in here. Now the whole point of this is so that it will flow into the areas where those towers are located, and it will help fuse everything together. That's kind of the idea here. That's why we're injecting so much of it. All of it, in fact. Just load that sucker up. Before it solidifies, it will flow to a certain extent into the areas where we need it to be. I'm going to try to kind of force it in there a little bit. There we go. Oh God, this stuff smells so bad. Really bad. Yeah, so I doped up over here where there's a clip that goes in. That's what this is for. That's going to prevent, and then we can dig it out after. Once all this stuff hardens, we're going to dig all that right out. Yeah. Yep. This is kind of like how plastic is actually made, you know, some chemicals. I mean, I'm actually getting it right over this so that it kind of adheres over it as one big piece. We'll never get this laptop apart again for any reason, but that's okay. It's a relic anyway. You know, that's what it is. It's a relic. It's never going to be used, you know, in the field again. We just need it to live. We need it to last. We need it to stick around. There are very few laptops from this vintage left in any condition. You know, so having this one in preservable condition is just, well, it's amazing. But that is now fully encased. I'm going to dispose of that spent syringe. And when this all hardens, now it's going to start heating up. Initial temperature readings are we're getting about 73 degrees. That's just above room temperature. So, all right, so we're getting some real temperatures here. What do we got? 128. 100, was that 219 degrees? Holy shit! 200, 198. Yeah, that's not a misread. 184, 149. This is 186. Stuff gets hot, guys. Just so you know, you can burn yourself with epoxy. Alright, you can actually see where it's softening the plastic here. It's kind of deforming it just a little bit, but not enough to cause me any concern. Alright, what I like about this stuff here is it requires no premixing. Most epoxies, well, every epoxy, you have to take two chemicals and mix them and then pour them into wherever you're, you know, whatever you're using them in, or wherever they're going. And that's a lot of work. Not only that, but you don't have a lot of time to work with it. Once you mix those chemicals, they immediately start reacting, and that's a problem when dealing with something like this. Because as you're pouring it, it's already hardening or gelatinizing. So you can do it, you know, with regular epoxy, but it's just you got to get those chemicals mixed just right, and you have to have really good timing. This stuff, when I discovered this auto mixing stuff, made possible by this, just this right here, I was blown away because it's like super glue. Boom, you have just enough time to work with it, but it's mixing as it's coming out of the syringe. So I like that for that reason. Real easy to work with. So you can kind of force it into tight areas like this, and it will flow just enough to, you know, in this case we're actually casting some reinforcements into the plastic using plasticine as a dam and or as a mold. So yeah, I had made a mistake. I had moved this piece of plasticine out just a little bit too far. And if I had let it go and let it cure, and it was already curing, I would have caused some problems. Look at this. It's already hard. And over here, yeah, this is already curing. Give it about an hour or two and it'll be hard as a rock. So after reassembly, we're now going to take a look and see how the hinge repair fared overall. So as I open it up, I notice about 1 inch or so of free play. Now that's not really a concern because that is because of the way the hinge pin locks into the bracket that secures it, that's secured to the LCD housing. And there's like a slot and a groove that it goes into, and there's just a little bit of play in that joint, and that's okay. That's not a structural deficiency that can cause issues down the road. That's just how it was made. But overall, the hinges have a there's only one hinge on this, one clutch anyway. Feels nice and firm with no cracking sounds or anything of that nature. So I deem this a complete and total success. If you want to know more about this laptop, there will be a separate video highlighting the NEC Versa. I almost said Nissan Versa. Highlighting the NEC Versa, and we're going to talk about its features and strengths and other weaknesses. But just for the sake of this video, let's go ahead and power it back up again. I've already rebuilt this machine with Windows 3.1, which is what it would have originally shipped with. The whole point of this project was to restore the laptop to as close to its factory state as possible, mechanically and in terms of software that it runs. It still has a dead clock battery, which is something I will address at some point. It uses a silver dollar sized battery, which is it's like a coin cell, only that friggin' big around. I've never seen a battery of that size, and I'm not even sure I can still get one, but I don't know the exact part number. I'm gonna have to. I forgot to write it down when I had it apart. So let's see if she boots up. So I installed a DOS 622, a DOS-based mouse driver, and Windows 3.1. There we go. This has a very nice LCD display for its time period. I've got an external mouse connected, so when that is plugged in, it actually allows me to use the external mouse. There it is. Everything works. No problems. Everything is good. Now when I close this, the display shuts off, but it stays running. So, alright. Thank you for watching, and I hope this helps some of you vintage laptop enthusiasts in preserving the historical machines that are desperately in need of saving. Thank you.